One of the best things about working in Java is how powerful its GUI extension libraries are, and just how quickly we can get a program up and running that not only has functional code, but also a slick, professional looking user interface to back it up and help anyone interact with our program. That's what we're going to be doing today, connecting this interface for basic username and password validation with some back-end code that we're going to write that will actually check two text fields to see if they're the ones we're looking for. To start us off, we have this basic GUI with a text field where someone can put a username and a password field where someone can put a password name that will just show up as stars. The source code for this GUI is so far completely auto-generated. We haven't touched it at all yet. It's just reflecting the design decisions we've made here. Before we can start writing back-end code to do our username password validation, our user is going to need a way to tell us that they've put in a username and password and they'd like it to be validated. This seems like a good job for the all-powerful button. So let's add a button to our GUI and we'll change its text to be submit. User will click it to submit their information. And now, when this button is clicked, we'd like to perform some programming logic. We want to check the username and password fields. And for this video, because we're just learning and doing things simple and easily, we'll just check them against some hard-coded text. The question is, how do we get from GUI to functional Java code? Generally, we're going to do this through the event-driven programming model, where the interactions that our user has with the GUI determine what Java code is executed, what back-end logic occurs. Another way to think of this is that we can set up pieces of our Java code, or methods, to listen for specific GUI-related events to occur, and then execute when they do. You'll notice that our GUI components, or controls, like our button, have a field here under their properties called events. These are all the things that could occur in relation to our control here. In theory, we could bind each one of these events to a method in our Java source code. And when this particular event occurred, whether because of user interaction or other code we wrote, our related Java method would be called. To let users click on our button and perform some coded action, we're going to be assigning an event handler to our action performed event. If we click on this field, we get an option already. Our GUI designer is suggesting we add a handler, JButton1ActionPerformed. That's kind of an awful name for a method that's going to be sitting in our code. JButton1 is pretty nondescript. JButton1 has been chosen though because it is the variable name assigned to our JButton when it's created in the actual Java code. If we scroll down, we'll see this actual declaration down here. And I'm sure we can change these settings, but NetBeans is letting me know that we probably shouldn't modify this directly because the designer is going to be modifying it too. So we'll just change the name of our button from the undescriptive JButton1 to submit button. When we make that change, we'll see that NetBeans has updated our source code, and now there's a submit button object bouncing around. This is a variable that starts with a capital letter, so we'll make one more change there. And now the suggested action performed by NetBeans is submit button action performed. When we head down to our source code, we'll see that an event has been created and linked with our J button. In this massive block of generated code that NetBeans has created to mimic our GUI that we've been creating through their tools, if we search for our submit button action performed method, we'll actually see it added to the generated code here. It's been added as the final call of this action listener placed on our submit button. Our action listener, of course, has one job and one job only, and that's to see if our button has been clicked. If it's been clicked, it's going to call our submit button action performed method. So here we can put some good old functional Java code. We need to do two things. We need to check the value of the password field, and we need to check the value of the username field. Passed into our submit button action performed method is only this action event. And while there's a lot of interesting and useful methodology attached to this event, the context of the action that caused our method to be called, it's not going to give us what we really need here. What we really need here is our password field and our text field, which fortunately are private members of our current class. Let's start with the username. That's jtextfield1, which we should probably rename when we get the chance, but we'll just roll with it for now because we only have one text field. If we remember, in the editor, under properties, this text field had a text property, which we've gotten rid of the text in because we don't want our username text field to start with any text. It's blank so that users know to put their own information in there. But it stands to reason if that's the property exposed to us in the designer, there should be a related property exposed by the object itself. And there is, getText. When we call getText, of course, we return the text currently stored in our text field. And we'll make our super secret username the very creative word username. This is, of course, a conditional statement. And we're going to want to make another conditional statement in addition. We want to ask our program if the text field and our password field which is going to expose a similar method, getPassword in this case, both equal the hard-coded string. And our secret password will be Java. Put an if in front of our conditional statement, some parentheses, and we're good to go. So now we need to give our users some indication whether or not they've succeeded in providing the proper username and password. Actually, before we go any further, getPassword actually returns a character array, not a string. So this comparison isn't going to work very well. To keep things simple, let's just assign this password value to a string and then we're good to utilize it as a string. Okay, what to do if the user has successfully input a good username and a good password? Well, I think it would be cool if we showed a pop-up dialog here. JOption pane provides us with the method show message dialog, which is a pretty cool way to impart really important, really immediate information to the user. It'll show a pop-up box, and it's pretty lightweight and easy to use. You may have to fix imports on this one. The only heavyweight information our message dialog needs to create itself is a GUI component to attach itself to be its parent. We could acquire the button through our action event, but that doesn't make a lot of sense because the dialog is not tied just to the button. It's really tied to the entirety of what this GUI is about, which is validating a username and password. So it'd be nice if we could tie this dialog box to the JFrame itself, the GUI's top level element. And in fact, we can. If we zoom up a bit to check exactly where we're writing code, we'll see that we're in a class, myGUI, that extends the JFrame class. This entire class is associated with the JFrame we're working with. So, to pass this JFrame as a variable to our showMessages dialog method, we simply use the this keyword. And now we just type in a message to show the user on password and username validation. So let's run our program and see what we've built. Here's the dialog, which there we go, which we've seen before and which we expect. Here's our valid username. I've typed in our valid password, Java. And when we hit submit, we get the pop-up dialog box, which we can move freely of our JFrame. Just to test things out, let's put in some gobbledygook, and we get nothing, no matter how many times we click. And a good username and no password also gets us nothing. Pretty cool. Of course, we've only just scratched the surface of what is possible with Java GUIs, and of course Java itself. The thing to take away from this is, well, two things really. One, creating Java GUIs for our programs is easy and in many cases painless. Sometimes the event handling model that GUIs to some degree force us to implement can even make creating our Java programs that are heavily reliant on user interaction easier than it otherwise would be. The other important thing that I cannot stress enough is that even though the GUI designer is awesome, it's possible for us to create this exact same project by simply sitting down and writing the Java code here. I'm not saying we shouldn't use the GUI designer, because there's a lot of code and a lot of well-written code that's been generated for us by the GUI designer, and that can save us a whole lot of time. But there's absolutely no magic happening here at all. This is all Java code making use of the Swing extension library.